Let's explore further how to do hypothesis testing for two population means. Let's remember the conclusion from the last example. We created a confidence interval around which we were 95% confident that the difference between the two population means would lie. To do hypothesis testing, we need to have a null and an alternative hypothesis. The pattern for these, for a left-tailed, right-tailed, and two-tailed hypothesis test are shown here, which is the same as what we've already learned. The difference is our parameter is the difference between mu1 and mu2. And we will compare that against some value of d0, d0 being the assumed difference or the hypothesized difference between the two population means. Our test statistic is shown here. This d0, that hypothesized difference between the two population means, we will subtract that from the difference between our two sample means and divide it by the standard error of the difference of the two means. Back to our golf ball example. Let's assume a significance level of 0.01. There are two approaches, as before with hypothesis testing, the p-value approach and the critical value approach. First, we need to develop the hypotheses. In this case, we are assuming, or trying to prove rather, that the mean of population 1 is greater than the mean of population 2. We'll restate that as mu1 minus mu2 is greater than 0. Because this is what we're trying to prove, we'll call that the alternative hypothesis, as in the research approach. Therefore, the null hypothesis is the opposite of that. Computing this test statistic, we get a z-value equal to 6.49. Given that this is a one-tailed upper tail test, we calculate the p-value to be less than 0.0001 for that z of 6.49. Because that p-value is much less than our significance level alpha of 0.01, we reject the null hypothesis. And restating, at a 99% confidence or a 0.01 level of significance, the sample indicates that the mean driving distance of the first golf ball is greater than the mean driving distance of the second. If we follow the critical value approach, for the alpha of 0.01, we come up with a z critical value of 2.33, and we will reject if our test z is greater than that. Well, our test z statistic is 6.49, obviously greater than the critical level, so again we reject the null hypothesis.